Hello students, in this lecture class we will discuss the topic half-range Fourier sine and cosine series. Okay, so let us start with. Uh, in our previous lectures we have discussed that how do we write a Fourier series of a function defined in the interval c to c plus 2l, and there we have discussed the case of even and odd function, especially when your function f of x is defined in the interval c to c plus 2l, sorry, minus l to l. Right? If your function f of x is defined in the interval minus L to L, and case 1, if your function is an even function, if your function f of x is even, in that case the Fourier series of the function is given by, in that case the Fourier series of the function f of x is given by the representation f of x is equal to a naught by 2 plus summation n varies from 1 to infinity an cos n pi x upon L, right? Means in that case, the value of the Fourier coefficient Bn is 0, and the value of the Fourier coefficient A naught is given by 2 upon L, 0 to L, f of x dx, and the value of the Fourier coefficient An is given by 2 upon L, 0 to L, f of x into cos of n pi x upon L dx, right? So this is a case number 1 if your function is an even function, and case 2 is if your function is an odd function, means if your function f of x is odd. Even function means that in that case your function satisfies the condition f of minus of x is equal to f of x, and in case of odd function the condition is f of minus of x is equal to minus of f of x, and in that case the Fourier series is given by, in that case the Fourier series of the function f of x is given by f of x is equal to summation n varies from 1 to infinity bn into sine of n pi x upon L. That is, in that case, the value of the Fourier coefficient a naught and an, both of them are 0, and the value of bn can be calculated with the help of the formula 2 upon L integral 0 to L f of x into sine of n pi x upon L dx. So basically what we get here, if your function is defined in the interval minus L to L and your function is an even function, in that case we get a Fourier series which contain only cosine term, like this type. If your function is an even function, in that case we'll get only cosine series because the value of the Fourier coefficient Bn is 0. And if your function is an odd function, in that case we'll get only sine series because in that case the value of the Fourier coefficient a naught and an, both of them are 0. Now what about the concept of half range Fourier sine and cosine series? So the half range Fourier cosine series. So what does it mean? It means that in this case we want to write the cosine series of the function f of x. And we know that we can get the cosine series of the function if your function is an even function. But in case of half range series, we find that our function f of x is defined in the interval 0 to L, in the interval 0 to L. And we want to write the cosine series of the function. Okay. So that kind of series is called the half-range Fourier cosine series, because in this case your function is defined in the interval 0 to L. So there is no question about even and odd function. But we are expecting to write the only cosine series of the function f of x. So we know that the cosine series of the function is given by a naught by 2 plus summation a n cos n pi x upon L, because in that case the value of the Fourier coefficient bn is 0. Okay, so the half-range Fourier cosine series of the function f of x defined in the interval 0 to L is given by f of x is equal to a naught by 2 plus summation n varies from 1 to infinity a n cos n pi x upon L, right? And in this case, the formula of a naught and a n is same as that of the cosine series which we get in case of the even function defined in the interval minus L to L only. So it is 2 upon L 0 to L f of x dx, and the value of the Fourier coefficient a n can be calculated with the help of the formula 2 upon L 0 to L f of x into cos of n pi x upon L dx. And the half range Fourier sine series, half range Fourier sine series of the function f of x defined in the interval 0 to L is given by f of x is equal to summation n varies from 1 to infinity bn into sine of n pi x upon L, and the formula for bn is 2 upon L 0 to L f of x into sine of n pi x upon L dx. So basically the difference in this case is when we discuss the Fourier series of the function, so we are assuming that the length of the interval is 2L, because the length of the interval is upper limit minus lower limit, right? So in that case, we are assuming it as L minus minus of L is 2L. Okay, but in case of half range Fourier sine and cosine series, our function is defined in the interval 0 to L only. That means in this case, the length of the interval is equal to L only. That means the upper limit of the interval, because in this case our interval is started from 0 only. Okay, so our interval is of the type 0 to L, like 0 to 2, 0 to 5, etc. So in that case the upper limit of the interval is equal to the length of the interval. So this is basically the main difference of the half range Fourier series as well as the Fourier series only. So what is the concept behind it? So when we are considering the half range Fourier cosine and sine series, basically we our function is defined in the interval 0 to L. So let us suppose that our function f of x is x defined in the interval 0 to 1. Okay. So what does it mean? It means that if we plot the graph of the function, the graph of the function is like this. F of x is equal to x in the interval 0 to 1. So in this case, there are two ways. If I extend my function, the same function, in the interval minus 1 to 0 as f of x is equal to x. So in that case, this function behave like a odd function. In that case, your function behave like a odd function. Okay, so in that case, we can write the sine series of this function in the interval minus 1 to 1. Because if I extend my function f of x equal to x in the interval minus 1 to 1, and we know that f of x equal to x is an odd function, because f of minus of x is minus of f of x, then your function behave like an odd function. So in that case, we can get the sine series of the function, right? And on the other hand, if we extend our function as this one in the interval minus 1 to 0, so in that case, our function behave like f of x is equal to mod of x in the interval minus 1 to 1, because this is a graph of mod x. this one. And we know that mod of x is a even function because f of minus of x is minus of mod x is equal to mod of x. This is equal to f of x. So this function is a even function because modulus of negative or positive number, its value will remain same. So it means that in this case, your function is a odd even function. In this case, your function is the even function. So in this case, we can get the cosine series. We can get the cosine series. So here, in case of odd function, we'll get the sine series of the function. Okay. So basically, either we extend our function in the interval -1 to 0, or I extend my function uh, as a mod of x, or I extend it as f of x equal to x. In both the cases, the nature of the function within the interval will remain same. Okay, so it means that we can express our function in the form of a cosine series also, or we can express our function in the form of sine series also. But that kind of series is a half range Fourier cosine series and sine series because actually our function is defined in the interval 0 to 1 only. Okay, so this is the concept of the half range Fourier sine and cosine series. Basically, we extend our function from 0 to 1 to -1 to 1. Okay, so if we extend our function like this, then we'll get our function as an even function. So hence, we can get the cosine series. And if we extend our function like this, then in that case, we'll get a odd function, and hence we can write the sine series of the function f of x. So that's the reason the formula of half range Fourier cosine series and half range Fourier sine series is same as that of even and odd function also. Okay, so now let us try uh, some problem based on this concept. So firstly, we'll start with the question. Question is find the or write write the half range Fourier cosine series, half range Fourier cosine series and sine series of the function f of x is equal to say 4 minus x square defined in the interval 0 to 2. Okay, so your function is defined in the interval 0 to 2, and we want to write the cosine series as well as sine series of this function. Okay, so let us firstly start with the half range Fourier cosine series. So let us firstly start with half range Fourier cosine series. So half range Fourier cosine series of the function is given by f of x is equal to a naught by 2 plus summation n varies from 1 to infinity a n cos of n pi x upon L. Now what is L in case of half range series? This is equal to the length of the interval because in this case our interval will start from 0 to L. So L is nothing but the upper limit of this interval. So in this case the value of L is 2. So here the value of L is 2. So it means that what will be your Fourier series? So Fourier series is a naught by 2 plus summation n varies from 1 to infinity a n into cos of n pi x by 2. And what is the formula of a naught? A naught is given by 2 upon L 0 to L f of x dx. So here the value of L is 2. So I can write it as 2 upon 2, 0 to 2. Your function f of x is 4 minus x square time dx. So this 2 and 2 get cancelled out. So if we integrate this function, so we can get here, this is equal to integral of 4 dx is 4x, and integral of x square is x cubed by 3. with the limit 0 to 2. Like I already told you that in the case of the Fourier series, we are going to use only few integration formula. So one of the formula is x raised to the power n dx. Its integration is x raised to the power n plus 1 upon n plus 1 plus c. So because we are performing the definite integrals, we are not using any arbitrary constant in this case, right? So the value of a naught is equal to, so on substituting upper limit and lower limit here, and 1 by 3 upper limit and lower limit. So this is equal to, so 4 into 2 is 8 and 2 cube is 8. So 8 by 3. So 24 minus 8 by 3. So its value comes out to be 16 by 3. So what is the value of A naught? The value of A naught is 16 by 3. So this is the value of the Fourier coefficient A naught. Now we want to find out the value of Fourier coefficient an. So what is an? It is given by the formula 2 upon L 0 to L f of x into cos of n pi x upon L dx. So here the value of L is 2. So it is 2 upon 2 0 to 2 f of x is 4 minus xk into cos of n pi x by 2 dx. So this 2 and 2 get cancelled. Sorry. So here we are again going to use the integration product rule, that integral of u into v dx. This is equal to u into v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on, where u is your algebraic function x power n and v is your sine function, cosine function, or exponential function. Like we have already discussed in our last video, that this is a special formula for the product rule which is applicable in most of the problem of Fourier series, right? Because in most of the problem of Fourier series we are having algebraic functions. In that case, we can use this product rule to evaluate the integral, where u is the algebraic function, u dash, u double dash, u triple dash, it simply represents the derivative of the function, and v1 is nothing but integral of v, v2 is integral of v1, and v2, v3 is integral of v2, and so on. Okay, so we'll continue this particular integration process till we'll get a non-zero value of this u function, that is algebraic function, because we know that u is algebraic function. So after finite many operations of differentiation, it will be constant and then it is zero. So it means that we need to perform this product rule formula for a finite number of steps, right? So let us calculate the value of a naught an with the help of this product rule. So in this case, what is your u? U is your this algebraic function, which is a polynomial function, and this is your v. So if we apply this formula, so we can get the value of an as, firstly, u, that is 4 minus xk, v1. V1 is integral of cos. So here we are going to use the formula of derivative of x power n. This is n times x power n minus 1. And we are using integral of cos and sine. Integral of cos ax dx. This is equal to sine of ax upon a. And integral of sine ax dx. This is equal to minus of cos ax upon a. So the first function u as it is 4 minus xk. In v1 is integral of cos. Integral of cos is sine ax, that is sine n pi x by 2 upon n pi by 2 minus. Derivative of 4 minus x square is my 0 minus 2x, because derivative of 4 constant is 0. Derivative of x square is 2x into integral of sine. Integral of sine is minus cos. So minus cos n pi x by 2 upon n pi by 2 whole square. Further, plus derivative of minus 2x is minus 2, and again integral of minus cos is minus sine of n pi x by 2 upon n pi by 2 whole cube. And if we again differentiate minus 2, its derivative is 0, so it means we stop our integration process here with the limit 0 to 2, right? So if we rewrite this expression, so we can get here. So now what we need to do, we need to substitute upper limit and lower limit in this integral. So we can get here an is equal to, so in the very first term, this is the first term, this is your first term, right? In the first term, this n pi by 2 is constant. So if I take it outside, I can write it as 2 upon n pi, 2 upon n pi. Now we are going to substitute upper limit minus lower limit. So when we substitute upper limit, that is 4 minus 2 square. 4 minus 2 square means 4 minus 4, and 4 minus 4 is 0. So it means that in the first term, when we substitute x equal to 2, it is 0. So the first term is 0. And when we substitute the lower limit here, lower limit is 0. So 4 minus 0 is 4. We get 4 times sine of n pi by 2 into 0. And we know that sine 0 is also 0. So basically this is sine 0. 4 times sine 0. And sine 0 is 0. So it means that your first term is completely 0. Okay, because on substituting upper limit it is 0. On substituting lower limit it is 0. Now come to the second term. So here we have a negative sign and negative sign and one more negative sign. So it means that this term is negative and this term is constant here, n pi by 2 whole square. So n pi by 2 whole square, its reciprocal is 4 upon n square pi square into 4 upon n square pi square. Now on substituting upper limit, so it is 2 into 2 is 4. So it is 4 times cos of n pi into 2 by 2, because x is 2, so this 2 and 2 get cancelled out, minus lower limit. So lower limit, when I put x equal to 0, so 2 into 0 is 0. So because 2 into 0 is 0, so the second term is again 0. Now come to the third term. This is your third term. So again this negative sign and negative sign get cancelled out. So n pi by 2 whole cube, this is a constant term. Constant term is 8 upon, so negative sign get cancelled out. So we have a positive sign plus 8 upon n cube pi cube into. Now on substituting upper limit, it is sine of n pi by 2 into 2 minus lower limit is 0, so it is sine 0. So here again we need to recall that the value of cos n pi, this is minus 1 raised to the power n. The value of sine n pi, this is equal to 0. The value of cos 0 is 1 and the value of sine 0 is 0. So we are going to use these four identities here. So sine 0 is 0, so this term is 0 and this 2 and 2 get cancelled out. Sine n pi, sine n pi is 0, so it means that this whole term is also 0. Sine 0 is also 0, so this term is also 0. So basically we left with only one term, this one. Okay, so what is the value of an here? So we can get the value of an as an is equal to minus 4 into 4 is 16 cos n pi. Cos n and pi is minus 1 raised to power n upon n square pi square. So this is the value of the Fourier coefficient an. Now the value of a naught is already known. It is 16 by 3. The value of an is minus 16 times minus 1 raised to power n upon n square pi square. So what is the half range cosine series? So the half range cosine series of the function f of x is given by f of x is equal to a naught by 2. A naught by 2 means 16 by 3 into 2 plus summation n varies from 1 to infinity an. An is minus 16 times minus 1 raised to the power n upon n square pi square. You can take this minus 16 also in bracket into cos of n pi x by 2. So this is the half range Fourier cosine series of the function f of x, right? So like I told you that what is the difference in this case? In case of half range Fourier cosine series, we are given an interval in the form of 0 to L. So the first thing is, in this case, the length of the interval is L. Whereas in case of Fourier series, we are assuming the length of the interval as 2L. So this is the difference in Fourier series and half range Fourier series. And in case of cosine series, we need to calculate the value of a naught and an only. And the formula for the Fourier coefficient a naught and an is same as that of even function, which we have discussed in case of interval minus L to L, right? So a naught and an, they are known, so we can get the half range Fourier cosine series of the function f of x, right? So this is one thing. Like I already told you, sometime the question is that we need to also get some value of the infinite series expansion, which we can deduce from this Fourier series. So if I try to rewrite this expression, so we can write f of x, what is your function f of x, which is 4 minus x square, and its value comes out to be 16 by 2. So if I cancel out this 2, so it is 8 by 3. Its value comes out to be 8 by 3 plus summation n varies from 1 to infinity 16 times minus 1 raised to the power n plus 1 upon n square pi square time cos of n pi x by 2. And if I open this summation, then it look like the term as when I put n equal to 1, then minus 1 raised to power 1 plus 1. It is when n is odd, then n plus 1 is even, right? Simply remember this thing, when n is odd, n plus 1 is even. So we can get here 16 upon pi square is constant taken outside. So we'll get here 1 upon 1 square into cos of pi x by 2. And when I put n equal to 2, that is when we put n as an even number, its value is negative. So minus 1 upon 2 square cos of pi x plus 1 upon 3 square cos of 3 pi x by 2 minus 1 upon 4 square cos of 2 pi x and so on. So basically in this case we can deduce two kind of infinite series. One is if we substitute the value of x is 0, that is if I simply convert this cosine term as a 1, and we know that cos 0 is 1. So it means if I put x equal to 0, then cos 0 is 1. Okay, so all these terms become 1 only, so we can get the value of infinite series 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square and so on, right? Because our function is defined in the closed interval 0 to 1. Okay, one more thing. If your function is defined in the open interval instead of a closed interval, then what can we do? Like in case of the periodic function, the value at the lower limit is same as that of the value at the uh, upper limit, lower limit of the upper limit value. Okay, but this is a problem of a half range series, and your function is defined in the interval 0 to 2 in the closed form. So I can get the value of the function at the point x equal to 0. So if I put x equal to 0, so here we get 4 minus 0 square is equal to 8 by 3 plus 16 upon pi square, 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. Why? Because the reason is cos 0 is equal to 1, because the value of cos 0 is equal to 1. The value of cos 0 is equal to 1. So if I take the rest of the term on the other side, we can get the value of this infinite series as 4 minus 8 by 3 is equal to 16 by pi square, 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. So if we take the LCM, it is 12 minus 8 is 4 by 3. 4 by 3 equal to 16 upon pi square, 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. So if I take this factor on the left hand side, so we can get the value of this infinite series as 4 by 3 into pi square by 16. It is 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. So 4, 1 by 4, 4 plus 16. So it means that the value of the infinite series 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. So value comes out to be pi square by 12. So this is the value of this infinite series. Okay. So how can we deduce this series? The first thing is simply open this summation. So from there only you will get an idea that what kind of infinite series that can be formed. So the next thing is according to the requirement, that if the question is that we need to find out the value of this infinite series with alternate sign, then in that case we simply need to make this cosine function as a 1, right? But other than this, if the question is that we need to find out the value of infinite series with all the terms are positive. So if I want to make all the term as a positive, so then what can we do? If I want to make all the term positive, it means that if I put here x equal to 2, if I put x equal to 2 in this particular part, right, what do we get? Because this is the infinite, this is the Fourier series of the function. This is the Fourier series of the function, right? So the Fourier series was f of x is equal to 4 minus x square, which is 8 by 3 plus summation n varies from 1 to infinity 16 times minus 1 raised to the power n plus 1 upon n square pi square into cos of n pi x by 2. Right? We know that cos n pi is equal to, we know that cos n pi is minus 1 raised to power n. And one more thing, minus 1 raised to the power n into minus 1 raised to power n is minus 1 raised to power 2n, which is equal to 1. So it means that if I put here x equal to 2, if I put here x equal to 2, then we left with cos n pi. And cos n pi is minus 1 raised to power n. So automatically minus 1 raised to the power n plus 1 into minus 1 raised to the power n, it becomes minus 1 raised to the power 2n plus 1. 2n plus 1 means it is an odd number because 2n is an even number. So 2n plus 1 is an odd number. So automatically its value is minus 1. Okay. So it means that we get all the terms as negative. 1 upon 1 square, 1 upon 2 square, 1 upon 3 square. So we can deduce the value of infinite series with same sign. Okay. So let us put here, we put x equal to 2. So 4 minus 2 square is also 4. So its value comes out to be 8 by 3 plus summation n varies from 1 to infinity. 16 times minus 1 raised to the power n plus 1 on n square pi square into cos of n pi. And the value of cos of n pi is summation n varies from 1 to infinity 16 upon pi square taken outside. So this is minus 1 raised to the power n plus 1 into minus 1 raised to power n upon n square. Okay. So this is minus 1 raised to power 2n plus 1. This is 16 by pi square into summation n varies from 1 to infinity minus 1 upon n square. Okay. So it means that we can get here 8 upon 3 plus 16 upon pi square with a negative sign. So it is into summation n raised to 1 to infinity minus 1 upon n square is equal to 0. So I can take this negative sign outside and we can take this 8 by 3 on the other side. So minus 16 by pi square into summation n varies from 1 to infinity 1 upon n square equal to minus 8 by 3. So this negative sign get cancelled out on taking this factor on the other side. So we can get the value of 1 upon n square as 8 by 3 into 16 pi square upon 16 pi square upon 16. So 8 1 the 8 2 का 16. So we can get the value of summation 1 upon n square. It means 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square and so on. This value comes out to be pi square by 6. So this is the value of this infinite series. Okay. So with the help of the same Fourier series, we have deduced the two infinite series expansion. One is the alternate series with positive and negative sign 1 upon 1 square, 1 upon 2 square, 1 upon 3 square. Its value comes out to be pi square by 12. And if we get all the positive term, then its value comes out to be pi square by 6. One more thing, because the value of 1 upon 1 square 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. Its value comes out to be pi square by 12. So if we add these two series, then you will find out all the even term get cancelled out, right? If we add these series, okay. So on adding, so we can get 2 times 1 upon 1 square, 1 upon 3 square, 1 upon 5 square and so on, and its value comes out to be pi square by 6 plus pi square by 12. So LCM is 12. So 2 pi square plus pi square is 3 pi square. Okay, so what is the value of 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square? This value comes out to be 3 pi square by 12 into 1 by 2. So 3 1 the 3 4 ka. So answer comes out to be pi square by 8. Okay. So if we add them, then we can get the value of odd power term. Similarly, if we subtract them, then you will get this odd term get cancelled out. We subtract them, right? Then you will get the series as 2 times. If we subtract them, then we can get the series of 2 times 1 upon 2 square, 1 upon 4 square, 1 upon 6 square, and so on. And its value is pi square by 6 minus pi square by 12. So 12 is the LCM, 2 times pi square minus pi square. Its value comes out to be pi square by 12. So in that case, the value of the infinite series. So in that case, the value of the infinite series 1 upon 2 square, 1 upon 4 square plus 1 upon 6 square and so on. Its value comes out to be pi square by 12. And if we divide it with this 2, then its value is pi square by 24. With the help of the same series, we can deduce the value of a four infinite series. Okay, so you can remember them as a value of the infinite series also, that the value of infinite series 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square and so on. Its value is pi square by 12, 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square. Its value comes out to be pi square by 6, and the value of odd term 1 upon 1 square, 1 upon 3 square, 1 upon 5 square. Its value is pi square by 8, and 1 upon 2 square plus 1 upon 4 square plus 1 upon 6 square. Its value comes out to be pi square by 24. Okay, so these are the four infinite series which we can deduce easily with the help of this series. Okay. So this is how we can find out the half range cosine series of the function f of x. What is our function here? Our function is 4 minus x square, right? So if we want to find out the half range sine series of this function, then let us see what we need to do. So for the same function, if we want to write half range sine series, so what is the half range sine series of the function? It is f of x equal to summation n varies from 1 to infinity bn into sine of n pi x upon L, because here the interval is 0 to 2, so the value of L is 2 only. Okay, and the formula of the Fourier coefficient bn is given by 2 upon L, 0 to L f of x into sine of n pi x upon L dx. So what is the value of L here? Here L is 2. So if we replace its value, so we can get 2 upon 2 integral 0 to 2 f of x. Here f of x is 4 minus x square, and your function is sine of n pi x by 2 dx. So this 2 and 2 get cancelled out. So we can get the value of bn as integral 0 to 2 4 minus x square into sine of n pi x by 2 dx. So I hope now you remember the formula, product rule formula, which we have discussed earlier, that this is your u and this is your v. So what is the integral of u into v? This is u. This is equal to u. What is u? It is 4 minus x square into v. What is v? V is integral of sine. What is the integral of sine ax? Integral of sine ax is minus of cos ax upon a, right? So we are going to use this formula here. Integral of sine is minus cos of n pi x by 2 upon n pi by 2 minus u dash means derivative of 4 minus x square. Derivative of 4 minus x square is minus 2x into integral of cos. What is the integral of cos ax? Integral of cos ax is sine of ax upon a. So integral of sine ax is, sorry, integral of minus of cos ax is minus of sine n pi x by 2. Okay, let me rewrite this because I think the space is less. So let me write here. Okay, let me write it in the next line. I'm writing here, this is minus of minus 2x into minus of sine of n pi x by 2 upon n pi by 2 whole square, whole square, then plus minus and then again plus. The next term is derivative of minus 2x is minus 2, and integral of minus sign is minus of cos become plus cos of n pi x by 2 upon n pi by 2 whole cube. Okay. And if we further differentiate, derivative of 2 is 0. So it means that we stop our integration process here in between the limit 0 to 2. So now if we substitute the upper limit and the lower limit of the function in this formula of Bn, then we can get here the value of Bn as, okay, now in the very first term, this is your first term. Here n pi by 2 is constant. So when we take the reciprocal, it becomes 2 upon n pi. Now let us start with the bracket. So here we have 4 minus x square into minus of course n pi x by 2. So when I put x equal to 2, 2 square is 4. So 4 minus 4 is 0. So it means that your first term is 0 minus. Now we substitute the lower limit. Lower limit is 0. So 4 minus 0 is 4. 4 times we have minus cos of 0. This is your first bracket term. Okay. Now come to the second bracket. Second term is this one. So here 2 upon n pi by 2 whole square is constant. So if we write it here, it is 4 upon n square pi square. Now let us see that what we get here. So in this case, if I put 2, now 2 into 2 is 4, but here we have sine n pi. So 4 times sine n pi. And when we substitute the lower limit, so 2 into 0 is 0. So it means that lower limit 0. And if we come to the last term, now this is the last term here, n pi by 2 whole cube. This is constant. So it is, when we take its reciprocal, it becomes 8 upon n cube pi cube minus 2 times cos of n pi, because 2 and 2 get cancelled out, minus of, on substituting lower limit, minus 2 times cos of 0, because when I put 2, then 2 and 2 get cancelled out, so we left with cos n pi. And when we substitute x equal to 0, then this is cos 0. So cos 0 is 1. So here again we are going to use the value of cos 0 is 1. The value of sine 0 is 0. The value of sine n pi is also 0. The value of cos n pi is, the value of cos n pi is minus 1 raised to the power n. Alright. The value of cos n pi is minus 1 raised to power n. So if we use all these identity here, then we can get the value of Bn as 2 upon n pi into this negative sign cancel out. So it is 4. This is the first term. And in the second term, because sine n pi is 0, so this term is 0. So automatically this whole term is 0. And here, so minus 2 cos n pi is minus 1 raised to power n. So it is 8 upon n cube pi cube into minus 2 times minus 1 raised to power n. This is plus 2. So overall we are getting the value as 8 upon n pi minus 16 upon n cube pi cube 1 minus minus 1 raised to the power n. So this is the value of the Fourier coefficient Bn. This is the value of the Fourier coefficient Bn. So if we substitute this value in the Fourier series, so we can get the value of Fourier series of x as 4 minus x square equal to summation n raised from 1 to infinity Bn Bn is 8 upon n pi minus 16 upon n cube pi cube 1 minus minus 1 raised to power n a time sine of n pi x by 2. So this is how we can get the half range Fourier sine series of the same function for minus x square, right? So this is the half range Fourier sine series of the same function. So in the last part, we have discussed how do we write the half range Fourier cosine series of the function f of x. And here we have discussed how to write the half range Fourier sine series of the same function. Okay. So now let us try the another problem based on the half range series. So this time we are considering, suppose I want to write the half range Fourier sine series of the function f of x is equal to say sine of 3x in the interval 0 to pi. So this time we want to write half range Fourier sine series of the function sine 3x. So what will be the half range Fourier sine series of this function? So firstly, what is the length of the interval? So length of the interval is in case of half range series, the length of the interval is equal to the upper limit because your interval is started from 0. So otherwise upper limit minus lower limit is also pi. So L is pi. So the formula of half range Fourier sine series is summation n varies from 1 to infinity bn sine of n pi x upon L. L is also pi. So this pi and pi can cancel out. So it is bn into sine nx. And what is the formula of bn? The formula of bn is equal to 2 upon L 0 to L f of x into sine of n pi x upon L dx. So we got L is pi, so it is 2 upon pi 0 to pi. Your function f of x is sine 3x and this is sine of nx dx. Now because it is a product of two sine function, so it is a non-linear trigonometric function. So in case of non-linear, we do not have any integration formula. So in that case, firstly, we need to convert them into linear form. So in the last video, we have discussed some trigonometric identities formula. So we have a trigonometric identity formula that 2 times sine A sine B. This is equal to cos of A minus B minus of cos of A plus B. If both the functions are sine function or both the functions are cosine function, then these are the formula corresponding to cos A plus B or cos A minus B, right? So in this case, sine A sine B, so the first one is cos of A minus B minus of cos of A plus B. So what can we do? We can take this 2 inside. So it is of the form 2 sine A sine B. So if we use this formula, then we can get the value of Bn as 1 upon pi 0 to pi cos of n minus 3x minus cos of n plus 3x into dx. So here we are going to use the formula of integral of cos ax. So integral of cos ax is sine ax upon a plus c. So if we use this formula, then we can get here the answer as integral of cos ax is sine ax upon a, and here also it is sine of ax upon a with the limit 0 to pi. But here what we find out here that here we have a factor n minus 3 in the denominator. So it means that this the formula bn is true for all values of n except n equal to 3. So even in the last video we have discussed that If your function is a sine or cosine, right? So in that case, if n minus a or n minus b, if n minus a is the integer, positive integer, in that case, because our summation varies from 1 to infinity. If we have a factor n minus a where a lies between 1 to infinity only, in that case, we need to calculate the value of a n or b n corresponding to that specific value of n also separately. Okay, like here we have n minus 3 in the denominator. So it means that in this case, we need to find out the value of p3 separately, because this formula of bn gives us all values of bn except for n equal to 3, right? Now let us substitute this value here. So on substituting upper limit and lower limit, we can get the value of bn as 1 upon pi. 1 upon n minus 3 is common. On substituting upper limit, sine of n minus 3 pi minus sine of 0. And here we have a factor n plus 3. Again, substituting upper limit, sine of n plus 3 pi minus sine of 0. So, like we have already discussed, the value of sine 0 is 0, and the value of sine n pi, n is any integer. Basically, this is true for any integral value of n. So if sine n pi is 0, so sine n minus 3 is again an integer because the value of n varies from 1 to infinity only. So it means that this value is also 0 and this value is also 0, and sine 0 is already 0. So we get 1 upon pi. This is 0 and this is also 0. So the value of bn is 0. But here n should not be equal to 3. And the value of n should not be equal to 3. So it means that bn is 0, but for n not equal to 3. So it means that for n equal to 3, we need to calculate the value of bn separately, right? So let us try to calculate the value of b3. So what will be the value of b3? So here we can use again the formula 2 upon L, 0 to L, f of x, sine. Now I am going to replace n with the 3. So it is sine 3 pi x upon L dx. So here the value of L is pi. So its formula is 2 upon pi, 0 to pi. F of x is sine 3x into sine of 3x dx. So sine into sine is the sine square, or even we can use this formula of sine A sine B, because if A is equal to B, if A is equal to B, so it is 2 times sine square A, and the formula of sine square A is cos 0. Cos 0 is 1 and A plus B become 2A. So the formula of 2 sine square is 1 minus cos 2A. So it means that if we take this 2 inside, then this is equal to 1 upon pi, 0 to pi, 1 minus cos 2 times A. What is A? A is 3x dx. So this is 1 upon pi, 0 to pi into 1 minus cos of 6x dx. So now we are going to integrate this function. So if we integrate this function, we can get the value of the Fourier coefficient Bn as 1 upon pi. Integral of 1 is x, and integral of cos 6 pi is sine 6x upon 6 with the limit 0 to pi. The integral of cos 6x is, integral of cos ax is sine ax upon a. Integral of cos ax is sine of ax upon a. See, this is the formula of cosine integration, right? So if we substitute upper limit and lower limit here, it is 1 upon pi is already outside. So x is pi when we substitute lower limit 0, and here 1 upon 6 common, sine of 6 pi minus sine of 0. But again, we know that the value of sine n pi is 0. So sine 6 pi is 0, sine 0 is 0. So its value is pi upon pi, that is, its value is 1. So this is the value of basically B3. Okay, so what do we get here? The value of B3 is 1. So what is the value of Bn? So basically we get the value of Bn as 0 if n is not equal to 3, and its value is 1 if n is equal to 3. So what does it mean? So the Fourier series is f of x, which is sine 3x. This is equal to b1 sine x, b2 sine 2x, b3 sine 3x plus summation n varies from 4 to infinity bn sine nx. Because its value is 0 when n is not equal to 3. So it means that b1 is also 0, b2 is also 0, and bn is also 0 for all other values of n, and the value of b3 is 1. So its value comes out to be 0 plus 0 plus sine 3x plus 0. So basically we'll get sine 3x is equal to sine 3x. Okay, so what do we conclude from here? So from here we get a very important result. This is a very important outcome. Especially this kind of question could be asked in MCQ type, right? So if our function is sine or cosine, if your function is sine or cosine, like sine 3x, and I want to write it in the form of a sine series, 1 to infinity bn sine of nx. So because left hand side and right hand side, both side we have a sine function only. So what can we do? We simply open this summation, b1 sine x plus b2 sine 2x plus b3 sine 3x plus b4 sine 4x and so on. So on comparing left hand side and right hand side, because in the left hand side we have only sine 3x, and sine 3x is only equal to sine 3x. So it means that because no other term is there in the left hand side, so it means that the value of b1 is 0, b2 is 0, b3 is equal to 1, b4 is equal to 0, and bn is equal to 0 for all n greater than or equal to 3 also. Okay, so what do we conclude from here? The value of the Fourier coefficient Bn is 0 if n is not equal to 3, and its value is 1 when n equal to 3. So in this case, there is no need of solving the integration part. We can directly calculate the value of the Fourier coefficient by comparing the left hand side and right hand side. Is it okay? So if we want to write the Fourier series of the function, like if we are given the function as a sine and we want to write sine series of that function, okay, so in that case we simply compare left hand side and right hand side to get the value of the Fourier coefficient Bn. Similarly, if we want to write the half range cosine series of the function, okay, can you try? Suppose that your function is f of x is equal to 3 plus cos of 5x, right? And you say x varies from 0 to pi, and we want to write half range cosine series. Want to write half range cosine series. So what is the cosine series? Cosine series is f of x equal to a naught by 2 plus summation n varies from 1 to infinity an cos n pi x upon, what is the value of L in this case? L is equal to the upper limit, that is pi only. Because in case of half range series, the value of L is equal to the upper limit of the interval. Okay, so this is pi. So pi and pi get cancelled out. So what do we get here? So we can get f of x, which is 3 plus cos 5x, which is equal to a naught by 2 plus, if I open this summation, this is a1 cos x plus a2 cos 2x plus a3 cos 3x plus a4 cos 4x plus a5 cos 5x plus so on. So if we compare left hand side with right hand side, this is a constant term. So constant term is equal to 3. So what is the value of a naught? A naught comes out to be 6. And what is the value of an? So clearly a1 is 0, a2 is 0, a3 is 0, a4 is 0, a5 is equal to 1 if the coefficient of cos 5x is 1. Okay, let us say I'm considering the coefficient as 6. I'm considering its coefficient as 6. So what is the value of a5? a5 is also 6 in that case, right? And the value of all other Fourier coefficient they are 0. So what is the value of a naught? It is 6, and the value of a5 it is also 6. So I can say that in this case the value of the Fourier coefficient a naught is equal to 6 and the value of Fourier coefficient an is 0 if n is not equal to 5 and its value is 6 if n is equal to 5. Okay, so this is how we can get the value of the Fourier coefficient in case of half wave Fourier sine and cosine series. So here we have considered a special case when your function is sine and cosine and we want to express the function in the form of a same series, right? Like in this, in case of sine function, if we want to express sine in term of cosine, then we have to calculate the value of Fourier coefficient because in that case we'll get the different value of the Fourier coefficient, right? But if we want to express sine in term of sine series only, in that case, because sine function is equal to sine 2x is equal to sine 2x only, right? In that case, we simply open this summation present in the right hand side. We compare the like term from left hand side and right hand side, and we can get the value of the Fourier coefficients easily. And if we want to express cosine series function in term of cosine series, we again open simply this infinite series, compare the like term from left hand side and right hand side, and you can get the value of these Fourier coefficient easily, right? So this is the important thing you need to remember here that in case of half range Fourier sine series and cosine series, basically the problem is similar to the case of even and odd function because the formula for half range Fourier cosine series and sine series is same as that of even function and odd function only. But the only difference is in this case your interval is not in the form of minus L to L, rather it is in the form of 0 to L only. So that's the reason this series is called the half range Fourier cosine series or half range Fourier sine series of the function, right? So you'll practice some more problem from this exercise part. If you still have any doubt or any query, you can post your query in the comment box. So if you want the solution of any kind of problem, you can ask me. I'll try to upload the solution of the same, right? So this is all about the topic Fourier series, right? So I'll share with you some the MCQ type question related to this particular topic. That what kind of question that could be framed from this topic. Okay, but I'm expecting that firstly you should revise this whole unit properly so that you can easily understand that what I want to convey through the MCQ type problems. Thank you. Have a nice day.